Congratulations for bringing the course Introduction to Computer Science with MakeCode and Microbit to your students. And welcome to this video, where you'll get a high-level overview of the course and instructional materials to jumpstart your preparation. Here's what we'll cover. We'll introduce the purpose and goals of the course, and look through the instructional materials to support you and your students throughout the course. We'll review the technical and material requirements, and then we'll walk through the most important preparation to complete before teaching. Now, you might find it helpful to have the course overview guide and Unit 1 materials open as you listen to this video so that you can pause the video at any point to look at the materials or resources in more detail. This course introduces computer science and programming concepts with a maker philosophy and a project-based approach to help students see coding as an important part of building creative solutions to solve a problem or serve a purpose. Now, it features Microsoft MakeCode and the BBC Microbit, and even if you don't have a computer science or coding background, you will be able to teach this course. You and your students are in for a fun journey as you work creatively with computer science concepts and build some awesome projects. Now, Microsoft MakeCode is a free programming editor that brings computer science to life with fun projects, immediate results, and both block and text coding options for learners at different levels. The Microbit was created by the BBC in 2015 as part of their Make It Digital campaign to encourage children to move from being consumers of technology to become actively involved in writing code and building new things. It's a pocket-sized computer with programmable buttons and an LED display that provides an easy introduction for programming and acts as a building block for all kinds of cool creations, from robots to musical instruments and more. Now, for support, you have two go-to resources. Frequently asked questions are found at makecode.microbit.org/FAQ. The knowledge base, found at support.microbit.org/support/home, is a repository of articles written especially to help answer common questions and solve common problems. Now, the course is made up of 12 units, each focusing on specific concepts and skills that are mapped to computer science standards. And you can expect approximately 22 to 30 hours of instruction and facilitation time. And there's approximately 16 to 27 hours of independent project-based activities for your students. Each unit is made up of 3 lessons. Now, keep in mind that a lesson may take up more than one class session. And Unit 6, the mini project, and the final project are unique in that all 3 of those lessons are dedicated to building and showcasing a project. Now, the lessons combine 4 types of activities that complement each other by reinforcing concepts, skills, and opportunities for creativity at different levels. So now, Lesson A, that's a way to introduce the unit concepts using a game or an activity. It's usually unplugged or away from the computer. Now, Lesson B puts those concepts into practice with guided activities. We call them birdhouse activities, where everyone codes the same program all together to focus on skill development. So birdhouse activities are kind of like those activities you did in woodshop where everyone makes the same thing. And they're easy to assess because you know what it's supposed to look like. But then the problem is a lot of schools stop after the birdhouse activity because they say, well, we taught the skills, we've assessed the skills, let's move on. But the most powerful learning comes with Lesson C, which is the independent project. And that's where students apply those same skills that they've already learned, but in new ways, and they exercise their creativity. Now, we're not asking students to learn new skills because we already know they have those skills from Lesson B, but we are asking them to apply those skills in a new context that's creative and meaningful to them. So they go hand in hand. The birdhouse activity and the independent project go hand in hand. The birdhouse activities are high on new skills and low on creativity. because everybody's doing the same thing. But the independent project is low on new skills, but it's very high on creativity, and so they complement each other, and it's important to do both of them together. Now, this course targets students that are ages 11 to 14, and it's designed to engage students with or without any coding experience by providing coding activities and optional challenges. We call them mods, which is short for modifications. But the course can also accommodate younger students of 9 and 10 who have some coding experience or maybe a bit more advanced skill. Now, by the end of this course, students will be able to describe and apply the following coding concepts. We're going to cover algorithms, variables, conditionals, iteration, coordinates, booleans, bits, bytes, and binary, radio communication, arrays, and the accelerometer. And students will demonstrate that they can synthesize those concepts and apply them in new creative ways through these self-directed independent coding projects. And you'll find the unit-specific learning goals in the unit summary section of the course overview guide and in each educator guide as well. Now, in addition to this video, you have a variety of instructional materials that we'll review now. So feel free to pause at your convenience to look at any of these in more detail and then continue watching. So these materials are going to include a course overview guide with an overview, a bill of instructional materials, technical and material requirements, course delivery, required educator preparation, and a glossary. Now, we also have an assessment guide with descriptions of the 5 types of assessments, all the answer keys, printer-friendly versions that you can distribute to students, and scoring rubrics. We have a standards alignment guide of all the CSTA K through 12 computer science standards that are addressed in the course and in each unit. And we also have a high-level overview booklet to promote the course to stakeholders such as school district administrators and government partners. Now, each unit has a short quick start video with a high-level introduction to the featured computer science concept, your key preparation, and activities for that unit. Each unit has its own educator guide with an overview of the goals and the standards that are addressed, any required unit-specific preparation and resources. For each lesson, we have a lesson plan outline, a before the lesson section with any prep tasks or required materials. We have a lesson details section with activity instructions and screenshots, and we have post-lesson assessments and reflections as well. Now, we also have, for each unit, a PowerPoint presentation that complements the content and the activities. And there's also a student workbook that has the learning goals, the activity instructions and tips, the mod ideas, the project expectations and scoring, and a glossary of that unit's key terms as well. Now, the technical requirements are in the course overview guide, but the educator and each student will need a computer, a laptop, or a tablet with an internet connection, a modern browser, and a USB port, and possibly an adapter if necessary. And then the students will need the microbit, the micro USB cable, and the battery pack. Now, to meet some of the project design specifications, additional accessories are recommended. So be sure to see this section of the guide for the complete list and purchasing recommendations for things like crocodile clips, servo motors, copper tape, and headphones or speakers. Now, in terms of software requirements, no special software is required because all the coding can be done in the online version of the MakeCode editor at makecode.microbit.org. If your devices use a Windows platform, Another option is the free MakeCode for Microbit Windows app that's found at aka.ms/microbitapp. Now, to complete the projects, you'll need an assortment of arts and crafts supplies. So you can see the guide for a complete list and purchasing suggestions. Now, the required educator preparation is detailed in the course overview guide, but we'll start by reviewing some care and safety tips. Now, the microbit is simple and it's safe to use with youth, and it's been specifically designed as an open microcontroller board with all of the electrical parts on display, which also means that there's a small risk of damage to the exposed parts. So there are some safety tips. For example, it's important to avoid generating static electricity by keeping the microbits in the anti-static bag when you're not using them, and by grounding yourself before you touch it by briefly touching a metal object like a chair or a table leg first. But the full list is on page 15, including links to printable safety tips. Now, be sure to develop equipment safety procedures with expectations to store, distribute, and collect the microbit and accessories as you would for other devices. Now, before teaching the first unit, you're going to need to master the course materials, to understand the core concepts and terms, and to know your tools. And now we'll highlight the most important tasks to accomplish these objectives. So be sure to review these sections of the course overview guide for all the details. So first off, to master the course materials, you're going to want to start by reviewing the full course overview guide. And you'll find descriptions of each unit in that guide. You'll want to review the Unit 1 materials in detail. And you'll want to give yourself enough time to practice all activities before every unit. Now, we suggest that you stay at least a unit ahead of your students, and that'll be really helpful for your planning and for your students' success. Now, your review of the materials we just described and practicing the lesson activities for each unit will help you to understand the concepts and the terms. But reference the recommended resources, the links, the glossary, and the course overview guide for any additional support. Now, you don't need to be an expert at coding, at using MakeCode, or the microbit, but you do need to know enough to present the content and be willing to learn with your students. And so the tasks in this section will help you to get a baseline level of understanding. So before the first unit, it's important to get familiar with the layout and the functionality in MakeCode. So in the course overview guide, follow the step-by-step instructions to practice importing a project, saving a file as a hex file, and publishing a project to get that sharing link that can be shared out. You'll want to learn the layout of an open project, which is the view that you and your students will work from the majority of the time, and then start coding. Now, if you're new to coding, start with the flashing heart tutorial that's found in the tutorials section of the Microbit MakeCode homepage. And if you have some experience, you'll want to jump right to the first coding activity in Lesson B of Unit 2. Now, you also need to understand the basic functionality of the microbit by reading about the features at microbit.org/guide/features. And then follow the step-by-step instructions in the course overview guide to practice downloading a MakeCode project to the microbit. Now, starting in Unit 5, sound and movement with the microbit are introduced, so be sure to give yourself some extra time to learn that functionality beforehand. Links to tutorials are provided in the course overview guide as well as in the Unit 5 Educator guide. Now, if you decide to use the MakeCode for Microbit Windows app, it's recommended that you download the app to all computers, laptops, or tablets before starting the course. Or you could lead your students to do this themselves in Lesson B of the first unit when students first start using MakeCode. For additional support as you prepare, please see the recommended resources in the course overview guide. And that's it. Thank you for introducing your students to computer science with Microsoft MakeCode and Microbit. Best wishes and enjoy this fun, engaging course, and we'll see you in Unit 1.